In this video, I'm going to be looking at the technical aspects of the TYT MD2017 or MD2017, whichever way you want to say it, in terms of its hardware, external design, internal design, electronics, etc., and comparing it to other radios that TYT made before or after or at the same time as this radio. Now, as far as I can tell, this radio was brought out in the latter half of, or mid to latter half of 2017. At the time, TYT claimed it's the first dual band DMR Tier 1 and Tier 2 radio designed for amateur radio use. Obviously, it's FM as well as DMR. Now, in terms of what TYT had been doing kind of just prior to that, they had the very successful MD380. Now, I've got an MD380 here. Now, apologies because this radio is actually held together by cable ties because I've had it to pieces so many times. So it's not, well, it does work actually. It's just it's in pieces. I've got the PCB, I've got the radio open in a number of different ways so I can get it to the internals anyway. Not actively working on this radio at the moment, but I may come back to it at some point. These wires are the programming wires directly onto the CPU. Anyway, so this was the radio which was very popular, I think from about 2015 onwards. This is a single band FM and DMR Tier 1, Tier 2 radio. So this is the UHF version. They did do a VHF version as well, but I don't think it sold very well. Most, I think, probably DMR repeaters were on UHF at the time. So this was very popular, and basically, as far as I can tell, its successor was the MD2017, which is this radio. Now, very soon after this was brought out, they actually also started making the MD760. Now, looking at the numbering schemes between 380 and 760, the 760 is obviously double of 380. Now, I don't have a branded MD760, but what I do have is a GD77. Now, a GD77 is effectively a rebranded MD760. So this is one of my GD77s. Well, kind of rebranded as Open GD77. Ignore these wires again. That's an external GPS I fitted on this radio. A lot of my radios are modified. So only shortly after they brought out this, within 6 months effectively, GD77s started to be available. Now they're obviously considerably different radio because if you compare that to this, basically these two radios have got color screens. This is a black and white screen radio, and internally actually they're quite different as well. These two radios use completely different, well, this radio here, the MD760 or GD77, this one is branded GD77, but there are some with MD760 written on. In fact, if you take out the PCB, it says MD760 on the PCB. I think they were only sold as MD760 in China. I don't know if they're sold anywhere else in the world as the MD760. So this is also, this basically provides pretty much the same functionality as the MD2017. So it's kind of weird that at the time they were saying this is their first, tier 1, tier 2 for amateur radio, and then shortly after this came out, and the electronics in this one are significantly, well, different CPU, different display, RF sections are kind of different. Anyway, and also very kind of within about a year of the MD2017 coming out, TYT also brought out this radio, which is a Retivis. This one's Retivis branded, but it's the MD UV380. Now the UV stands for UHF VHF, so it's the dual band version of the MD380, and as you can see, they're kind of very similar, really. Not a lot of difference between them physically. Sorry, I've taken the knobs off this one. So, but basically, very similar looking radio. But really, the hardware in this one's significantly different to the hardware in this one. The hardware in this one, apart from having an older DMR chip, the RF hardware is quite a bit different in terms of the actual. This one's got a transceiver chip, single chip transceiver in it, and this one is kind of more old school in terms of separate IF chips and that sort of thing. Anyway, oh, and separate PLL chip to generate the frequency. Anyway, so that's kind of a history and where this radio lies in terms of what TYT was doing at the time. I do find it quite odd that within a few months of maybe 6 months of 2017 coming out, that I'll move it out of the light, that this came out anyway, and it would have probably really killed sales on that, because I think probably this is cheaper anyway because of the black and white display. Anyway, so that's the quick look around the outside, or comparison with the radios that came before and after this. So this radio claimed to be IP67 in that it's fully waterproof and effectively fully dust resistant or dirt resistant. Now that may be in the case for most of the radio, but the Achilles heel of this radio is this trackball thing. It was the one defining feature of the radio, and it's probably the one thing that kind of actually killed it in terms of them not producing it very long. They decided to use a small trackball here as for the navigation for up and down on the menus, and also as left and right. I mean, additionally, this radio's got these P1, P2, and it's got some up and down buttons on the side as well. So quite why they decided to do that, and also why they didn't just use push buttons. See, by comparison, slightly later on, within probably a year, Baofeng brought out the DM1801. Now, again, ignore the fact that this radio is partially in pieces, because a lot of my radios are in pieces, but what Baofeng did was they've got this kind of rocker control, and as you can see, it's very similar to this, but it actually does function. So really, TYT would have been much better off doing that, and I'll kind of also explain why now. In terms of this little thing here, the whole radio is kind of waterproof-ish, but this thing here, where the trackball is, this just completely pops out. This isn't glued in at all. Well, if it is, it's not with some very strong glue. You can kind of just prise it out very easily. Inside, there's this trackball mechanism which literally is not bolted in. I mean, when I took this apart, I was astounded to see that this trackball thing just fell out, basically. Now, the reason that they kind of claim that this radio is waterproof is because if water was to get into here, this is actually sealed to the inside of the radio. There's some sort of epoxy glue in there. So that is sealed to the rest of the radio. However, if you were to get any water into this, water would flow into this and just fill it up. And basically the water would get into all the mechanisms of this trackball. And the trackball is exceedingly mechanically fragile, in that it's got rollers on all four sides. And when you push it down, it actually rolls kind of only one roller moves at a time. They must have a sort of a non-return mechanism such that if you push upwards, let's say only one of the two rollers that's actually in contact, well, the like either the top roller or the bottom roller, only one of these is actually rotating. And if you look carefully, it may be difficult to see on the camera, but there's these little black things. Now, these are the ends of the rollers, and they're actually got little tiny magnets. It's like a magnetic rubber strip, and as you turn it round, basically that rotates, and there's probably a north pole on one side and a south pole on the other, or maybe four poles. I don't really know. Anyway, because actually they're relatively magnetic. If you were to put like a small screw or something near it, it starts to pick it up. So anyway, but obviously getting any form of dust or seawater would be particularly bad for this as well. Not because it's electrically conductive, but purely because the salt's going to dry out, and then this is going to be useless. I mean, and also I wouldn't like to take this out into any dusty environment. You know, the Australian bush here, well, anywhere basically. A lot of places in Australia are very dusty because of we get a lot of dust blown in from the red centre, which is effectively a desert. So yeah, this is going to kind of pack up fairly soon if you were to kind of use this outdoors. Anyway, but yeah, that's been its real Achilles heel. It just doesn't work very well. In fact, this radio that I bought, I don't know if it was a factory reject. I just bought it off AliExpress a year to 18 months ago, and it the down worked, down direction worked with official firmware, and the left direction worked, but the up and the right didn't work. I mean, fortunately, most of the menus actually kind of pushing left does make the menu go up. Bizarrely, now I wonder whether they did that purely because you know, these things just failed all the time, and the up and down didn't work properly, so they could get away with basically only half the directions working. But then you kind of lose the right and you lose the up, which probably have some other functionality. So I also haven't tried it, but in the official firmware, I believe there's a mode you can select for no trackball. So I'm not exactly sure what user interface that then does in the official firmware. Anyway, right, excuse me, I have to have a cough. That's a post-COVID cough from a couple of months ago. Anyway, so just having a bit more of a detailed look inside there, you'll see there's actually these black dots are little Hall sensor chips. So when you rotate the trackball, these things are designed to pick up the pulses from the magnets and then send that back through. And I'll show you inside here in a minute. It's also got just a regular dome push button. Now that still does work on my radio, which is good. Anyway, so that's the complete madness of the trackball on these things. This LCD is a standard LCD screen used by loads of, well, the MD380, the UV380, and you know, various other radios of this ilk. It's a standard. Must admit, I forget the size of the LCD display. Oh, sorry, in terms of resolution. Yeah, it's reasonable resolution. You know, it's a reasonable size screen. It's relatively bright. You know, kind of can be used relatively well outdoors. Just physically looking at this radio, on the side it's got some up and down push buttons, it's got PTT, it's got a blue function button, and on the top it's got an orange button, and there's an LED, red-green LED. I know this radio is also sold, or was originally also sold as a Retevis RT82. I don't know if the case is exactly the same, but I do know that this is different. I think this is a black button rather than blue. This maybe is orange here, or maybe black with an orange surround on that button or something. I've also been told that potentially the orange button is square, so which on the Retevis, though I haven't confirmed that. So in which case then the whole case is different, so maybe well, at least the moulding's different, but yeah, don't know for sure basically whether that's the case. But apart from that, what the Retevis one, you know, appears to be identical. Retevis tend to do this though. Retevis tend to buy radios from other manufacturers, rebrand them, and often put them in a new case or a very similar case, just slightly modified case, but basically with exactly the same internal hardware. Case in point I could show in a minute is the Baofeng 1701, which I forget what RT designation that's sold as, but basically it's the same internal Baofeng hardware, but in a slightly different case. And to be honest, the Retevis cases are sometimes better than the TYT or Baofeng cases. Now this radio I've already disassembled, which is why I'm not showing you the back of it. Oh, should say it's got this kind of IP67 compliant connector on the side. Annoyingly, this radio didn't come with a cable. And I would have said a cable's probably essential, because I don't know if this cable's the same as any other TYT waterproof radio or not. Potentially it is, but it's probably not the same as a lot of other radios. So you definitely need to have the programming cable if you were to buy this radio. I should also point out that this radio is no longer in production. I think it went out of production a couple of years ago, probably because it's been superseded by the MD UV380. There's quite a few of them around still in stock. I know a dealer I spoke to in the US said they still have some in stock. I don't think they're a big seller, mainly because of the trackball. I've seen them also advertised on eBay at quite a high price, to be honest. Kind of in the $200 mark, when kind of radios with equivalent functionality nowadays would be something like this Baofeng DM1701, which in US dollars is probably about 75. Very, very cheap, but basically, almost the same functionality, except the Baofeng DM1701 doesn't have a GPS option. And there is a Retevis version of this radio as well, though I don't think that's being made anymore. But the Baofeng 1701 definitely is still being made. Anyway, so digressing on from that, now I've already disassembled this radio, so I'll kind of show you around the what it kind of would look like if you took it apart. So if you take it apart, it's inside the back of the radio. You'll kind of see this. Well, normally that sits in there. Okay, so which is pretty much the standard. It's pretty much the same thing. If I was to pop open, say this UV380, it's kind of basically the same thing. Obviously, this radio is slightly taller than the UV380, but yeah, it's basically, that they all have pretty much a standard design, with an aluminium chassis with main PCB mounted to it, and usually another board inside the front panel. I don't know if this is the same for other manufacturers, e.g. Anytone or anybody, because I don't have their radios. I'm focused basically on the kind of the budget end of the spectrum, as it were. Anyway, so there's the front panel PCB. Now the front panel PCB joins to the main PCB, which is that one there. I'll just take it out of its chassis. I'll come back to the chassis in a minute in terms of the heatsink capabilities and the RF screening. So if you were to take the back off the radio, pull it apart, which is a little bit difficult because it's got rubber seals around the edge, but around the top and all sorts of places. So you end up with the front panel PCB, which is quite large, and the main part of the radio PCB. Just briefly, just focusing on the front panel for a minute, it's got quite a big connector with these little kind of snap-on plugs at either end. Now I don't know how many pins they are. I'm guessing around about 24, something like maybe 30. So there's quite a lot of signals going backwards and forwards between the main PCB and this. Whether it really needs 24, I don't know, but probably not. The thing is, it does have the USB speaker mic and PTT connections that are all through there, so that's probably about 10 connections. The display connector is there. I'll try and just not fool the autofocus on my phone. So that's the ribbon connector to the display. This is the ribbon connector to the trackball and push button PCB, which is actually kind of sealed. You can see some kind of glue in there. So basically, when they make this, they must put a load of effectively silicon sealant or waterproofing in behind, and they squidge this little kind of waterproof circuit board into there, so then no water would actually ingress through there, but it would fill with water. There's a few ancillary components, not quite sure what they do. Oh, the mic's up here as well, and the speakers in the front panel. The speaker doesn't connect through the ribbon cable. Again, not sure why. I guess maybe current carrying capacity. so it's on a flying lead. The lead's not normally this colour. I've put a longer lead on already. So yeah, so that's the front panel. So I'll just get that out of the way for a minute and kind of focus on the main board, which is potentially the most interesting part of it. I'm just going to try and turn this on its side and move the camera down a bit and see if I can kind of get a bit more, get that light out of the way. So, okay, so this is the side of the PCB which you'll kind of see the first really if you were to open the radio up. It's kind of quite similar to a lot of the other TYT radios. It has the STM32F405, I think it is, VGT processor. So that's 168 or thereabouts megahertz 32-bit processor. It's got, I think, 1 meg of internal programming storage for the program and fonts and that sort of stuff. That chip there is the flash chip, so that's a 16 megabyte flash memory. There's room for another chip here. This solder blob is what I put on to get a ground connection, because that's a nice easy ground connection to get to. This will be the audio PA chip, which is fairly common. It's I think it's a TDA something or other. Now here is one of the PAs, RF PAs. And the I should have pointed out previously, because I've taken, when you have to take the radio apart, you have to remove the antenna connector to get it out of this PCB out of the chassis. So what I've done, so I can actually continue to use the radio, is I've made a patch lead with a SMA on the end of it. Anyway, so I believe this is probably the VHF PA, because the UHF PA is on the opposite, directly underneath here on the opposite side of the board. But I'll come to that in a minute. I think potentially this is some broadband PA drive. I'm not quite sure what this is, but when we look at the other side of the PCB, you'll see that there's kind of no equivalent to that, or not much, on the other side. So whether this has got some sort of initial PA stage and then kind of a finals, or maybe even 2, because interestingly it's actually got 3 different supply rails that are required to be turned on by the processor in order to produce RF. There's kind of PA1, PA2 and band select, and all 3 of those need to be kind of correct. Well, PA1 and PA2 and the band select, which whether the power goes to the UHF or the VHF PA. So it's kind of like potentially there's a initial PA, maybe a broadband PA, before it goes into the individual single band PAs. Should be pointed out, this is the GPS version of the radio. It's got the GPS antenna on this side of the board. This is pretty much the same as the UV380. Now the UV380 GPSs originally weren't very good. I don't know whether this one's any good or not. Kind of placement of this antenna is not ideal, because it's kind of faces out through the, kind of back to the radio, that kind of faces out over here really. So when you're using the radio, the GPS will be facing in towards your face basically, and not looking up at the sky. I mean, the better location would probably have been if it was at the top or something, but anyway. Look, they probably do work, but probably just not that well, or not as well as that they could work. The other thing is that the GPS modules that were in these weren't very good. I mean, you know, they're now coming on 7 years old, I guess, 2017 to 2024. So really the RF, quality of RF components and things has come on in that time. Oh, I should point out another couple of things if I can get to it. Sorry, I'll just get this little thing and get it in shot. That little thing there is so it's the rattle of all the screws that I keep in the jar. The LEDs are on a little kind of daughter board thing. So when you take this out, you actually have to, before you can take it out, you have to unsolder this because the LED, well, I don't know if it was strict, I can't remember if I absolutely had to, but basically that is just soldered on there, and then this has got the red and green LEDs, rather than use a light pipe. A lot of the newer radios, they just use a piece of kind of clear plastic as a light pipe for the LEDs, but this one's kind of got this little daughter board thing. Well, you know, I guess it's strong enough, really. I mean, it's just relying on the solder to kind of hold it, but it's not, it wasn't glued in or anything. You know, there's no other strain relief. I mean, they probably should have put some glue on it. I don't think they did, though. Can't really remember, but I don't think it's got any glue anyway. That will go back in my jar of components that came out of this radio. So that's this side of the radio. Oh, sorry, this bit here is where the push buttons are, so the PTT. And it also has an orange button, which is a physical switch on the top of the radio here. This is pretty much like a lot of the other radios. They have a button on the top. Now this is, for some reason, notoriously fragile. Not on this one, but quite a lot of radios, this ends up breaking. Maybe just, you know, the strain relief on it isn't so good, or, you know, potentially they should have used some sort of epoxy on it, but they tend not to glue things down. I guess it's an additional process, it's going to take time. Anyway, so that's the underside of the PCB, or one side of the PCB, and this is the other side of the PCB. These are just the standard power connectors to the battery. I'm pretty sure that they're the same way round as the batteries in the other TYT radios. Really, they just use the two outers. Now, I can't really remember which is which, so I think this one's a positive, but really you'd have to check for yourself, because it's quite important, obviously, if you were to be attempting to power this other than via the official battery, that you get the power around the right way. While I was testing this, what I actually did is I found here what appears to be a fuse. Trying to see where I soldered on. I actually soldered onto a couple of points on the back of the radio. Oh, here, basically, this is a fuse, and this is the incoming power from the battery. So I actually soldered a wire onto here and a wire onto there, so I could power it from a loud power supply. So, because obviously I couldn't run it with the battery slapped on here. Anyway, so this is the other side of the PCB. Now, my guess is that this is the UHF PA, because the coils here are significantly smaller than the coils on that side. So, you know, obviously meant to be around about 2 to 3 times smaller, and they do look about 2 to 3 times smaller. So, believe this is the UHF PA. Now, it doesn't have all of the additional kind of circuitry that this one's got here. So my guess is this is like a pre-stage for the PA, which is broadband perhaps, and then this is the actual band dependent PA, and that would kind of make sense in terms of the power signals that need to be switched on to two different PAs effectively. Well, not just the dual band anyway. Two different parts of the PA. So that's that. Now, if those two are the PAs, then we need 2 preamps. So my guess is that probably these 2 sections here are probably the preamps. Now this one looks a little bit bigger than that one, so maybe that's VHF. Kind of really hard to know which one's which, but potentially those 2 are the preamps for the 2 bands. While we're looking at this end of the board, this is this Jumpstar GPS module that's fitted in these radios. It's really not very sensitive. It's not a very good module. On some other radios I've known people remove these and fit them with a more modern module, and the radio works, GPS works much better. So you'd have to be kind of quite careful removing that off, that you didn't damage anything. I mean, it could be done, but yeah, it wouldn't be a simple job. The power and volume control here. Now, the key difference with this and the UV380 is that this actually is a direct volume control. So the audio from this kind of end of the board, goes up through here, through this actual resistor, variable resistor, before it goes into the audio amplifier chip here. So this physically controls it, whereas the UV380 went for a different system, which I really don't particularly like. In the UV380, they use the potentiometer in here just purely as a voltage divider. That produced a varying voltage depending on the volume level, and then the CPU read that voltage and then used the gain control in the DMR chip to vary the audio volume. I mean, that does allow the CPU to override the volume, so it could turn the volume up, or it could beep the radio, make the radio beep or something, even when the volume control was turned right down. But it does end up being kind of sluggish. One of the complaints is with the radios without direct control, that you kind of turn, especially with the official firmware on some of the radios. I think maybe the GD88. One of the complaints with that, it must have the same system, because there's a considerable lag on the volume control, but not on these because it's direct. It's not that bad on the UV380 either. I mean, it's really just a question of getting the firmware right. Anyway, so moving back down now, what was initially I thought a really useful feature in this radio is it's actually got two transceiver chips. These two chips are identical. These are these AT1846S, so it's Alpha Tango 1846S transceiver chips, dual band, or actually the tri-band transceiver chips. They do the 220 megahertz band as well, though there's no RF sections in any of these radios really supposed to handle the like 220 megahertz band. Anyway, so I was quite excited that this is a true, in theory, should have been a true dual receive, dual transceive radio. Unfortunately, on closer inspection of this chip here, it doesn't have half of the connections that would be required for it to be full transceive. In fact, the only connection this has got is the receive RF connection. It doesn't have the transmit RF connection. It doesn't have the mic input connection. It doesn't even have the audio out connection. So this chip, basically, the only thing this chip is really useful for is to tune it to a frequency and monitor the S-meter, or the signal to noise ratio. So it's the RSSI, and the noise is about the only thing that this can be useful for. So the radio can be used, well, it would work better in terms of being for dual watch, because you could set this to a completely different frequency while you're listening to that frequency for the one coming through this transceiver, because this transceiver is the one with everything connected. But you kind of can't get this thing ready. You can't just switch to the audio on this one. In order to listen to the other frequency, the firmware would actually have to tell this one to change frequency. I'm not sure in terms of, say, the receive connections. I think probably they both just connect, both the receive preamps, probably just both join together and just both feed both radios. I don't see any signs of any kind of switching between here and these two that would allow kind of, this one to get the VHF, let's say VHF RF, and this one to have the UHF or something. I just don't see any signs of that at all. So probably if you were to try to get this thing to do anything better in terms of during dual watch, then you probably couldn't do dual watch on different bands, because you couldn't, unless you just turned on both the RX preamps, which you probably could do, to be honest. I've not experimented with doing anything like that, so that's maybe possible. I mean, you're not transmitting, so apart from maybe sporadic interference, in QRM, not sure if it would overload the inputs. Could give it a try, I suppose, and see how things go. Anyway, so that's kind of really disappointing. So this prevents it doing something like single frequency repeat. You know, maybe even, well, I don't think it could transmit and receive at the same time. So I'm sure that you know, there's no filtering. So you'd end up, I'm pretty sure if you transmit, it shuts down the front end, so there's protection diodes and all sorts of stuff, so it wouldn't really be in use. Even if this did have its audio output connected, I don't think it would be useful for satellite operations. But I could be wrong. You know, potentially, you know, maybe that would have been possible if they had just connected up the audio output from here. So that was a really dumb move. I mean, I'm kind of not surprised that it can't transmit on both at the same time. So, you know, with it not having the transmit pin connected, that's not a big deal. That's not unsurprising, but it is surprising there's no mic audio or even output receive audio. So yeah, really disappointed with that. Center, excuse me, is the master clock oscillator, master reference clock oscillator, which is used for most things. It's temperature controlled, temperature compensated voltage control crystal oscillator. So yeah, that's kind of fairly standard fare for all of these radios. This chip here is the DMR chip. Well, I say DMR, potentially DMR and FM. The UV380 uses this chip for both FM and DMR. I don't know whether the official firmware in this radio uses this for both FM and DMR, receive and transmit. Now, it does have an audio multiplexer, so you can, well, it's possible to select the audio output from here, from the transceiver chip, and feed it directly to the speaker or via the amplifier, or you can get the audio signal from the C6000 DMR chip. Sorry, I'm just going to cough again. Need a drink here. Sorry for the wobble on the camera, so a short break there. Have a cough, basically. So yeah, I don't know whether the official firmware uses direct audio out from these or this chip, or whether it routes the audio through there, through the C6000 DMR, or you could call it a DSP chip, really. Anyway, and then that audio then goes out to the speaker. Yeah, don't really know what the official firmware does. In terms of transmit, there appears to be an audio multiplexer that controls the audio input from the mic into here, the mic input, because if that MUX is switched over to the wrong way, you don't get any FM transmit audio. Now, whether it's a MUX and when it's in the other direction it feeds the audio to here, I don't know. I have tried to trace the audio, the mic signal, but actually I just can't actually, even using my oscilloscope. I think it should be on one of these pins here, where the mic audio should be going in, but I couldn't see any, which is kind of weird, so I'm not sure if I was doing something wrong. But anyway, so I couldn't see any mic audio here, and I couldn't see any mic audio there, but so that's kind of by the by, really. Not sure what this chip is. It might be some sort of encryption chip or something. A lot of the radios have that. I think it's got something like written on it 2100H21JRC or something like that, but quite what that is, I don't know. To be honest, I don't think it's actually used. Or maybe it's used in some alternative uses for these radios, because no doubt these radios, though this one was touted as being a ham radio, no doubt it was really manufactured for commercial use and then just kind of repurposed. Anyway, so that's a general takedown. One thing I have kind of noticed is that with the PAs being on opposite sides of the board, then normally they use the chassis as heatsink, and through this kind of conductive rubber. So when that's down on there, then that, this FET here presses onto that pad there. but there isn't going to be any heatsink for these FETs, which is kind of kind of probably not ideal either. I mean, these are not going to be worked so hard. This is the VHF, and they're not going to be driven. The FETs are not going to be working as hard on VHF to produce the same level of power. So maybe they thought they'd get away with it. Or, to be honest, actually, I think maybe this is a piece of clever kind of thermal design, because the chip here, the FET here, like the final power FET, is basically on the opposite side of or very close to the opposite side of the board to the VHF one. So probably what they've done is they've probably bonded through there. I'm just going to get a magnifying loupe if I can find one and see if I can see any bonding. So excuse me while I take this out of shot, because I don't suppose this is going to no, I don't suppose I'll be able to view it through this magnifying loupe on camera. I'll give it a go, but it's not working too badly. So where are we? We'll be down here somewhere, don't we? Yeah, I think maybe there is. Sorry, it's just not coming out on camera. I'm just going to take it away and have a kind of look at it closely. Yeah, it's on quite a large pad, and I can see quite a few bonding vias. I mean, I can see 6, and I think there's some in behind here, so it's probably not coming out on the camera and not through here either. But which one is which? So it's that one there. Yeah, so yeah, it's probably not going to be in focus, but there's basically heat bonding vias through here. So I guess the idea is that the heat is transferred to the FET on the opposite side, and then that transferred into the thing. And because the VHF FET is not going to be working as hard as the UHF FET, then maybe that's good enough. I mean, I've not heard any reports of these things overheating, but I guess probably overdriving the FET or transmitting for a long time at high power on VHF, maybe not ideal, but it's probably okay. Yeah, so I think that's basically about it. There's not much else that I can analyze on here. I mean, it's a shame I don't know what some of these do, but yeah, they don't. I'm pretty sure they're not used for normal, say, amateur usage anyway. So that's it. That's my kind of technical analysis, the best I can do anyway. I mean, I'm not a trained RF engineer, but I think these things are kind of fairly self-explanatory. So I hope you've enjoyed watching this video, and I will be making another MD27 video probably in the coming weeks.